everybody, my name is Hannah and my project presentation is on the heart rate and body temperature dataset. My dataset originally had 130 values and my sample now has 30 values. For my summary sheet, I chose the body temperature data, and right next to it in column B is the standardized data. This represents how far these values are away from the mean in terms of standard deviations. Next, if we zoom in just a little bit, we have our frequency distribution table, which includes the minimum, maximum, number of classes, class width, lower class limit, upper class limit, and the frequency. If we scroll down, we'll see the mean, mode, mid-range, range, variance, and standard deviation. And directly next to it, we have a 5-number summary. The 5-number summary just gives us a picture of the data, similar to a histogram, but in numbers. Speaking of histogram, we can inspect the histogram. The histogram is skewed to the right, and the most relevant measure of center for this data would be the median. This is because the median is more resistant to outliers compared to other measurement of centers. The closest measurement is the mean, and I know this because if we scroll down, or where is it? There we go. 97.5 is the closest to 0 for our standardized data. And if we look at the mean, it's 97, 49, 33. And in this data, the two standard deviations above the mean is the 96.3 and close to 96.7. This proves this law because those are outliers. Here's the confidence interval. The question I'm answering is, using your sample, test the claim that the mean heart rate for this population exceeds 70 beats per minute using a 90% confidence interval. The point estimate is 71.87. The standard deviation is 511, and the confidence level is 90%. N, or sample size, is 30. The lower is 70.28, and the upper is 73.45. And my conclusion is that I am 90% confident that the mean heart rate for this population exceeds 70 beats per minute on a list between 70.28 and 73.45 per one person. Moving on, we have the hypothesis sheet. The question I am answering is, using your sample, test the claim that a majority, 50% or above, of the body temperatures for this population is below 98.6. If we look at our data, the counter argument for this question is all 0. We have none that are above 98.6. The n is 30, our p-hat is 0 because 0 divided by 30 is nothing, and the claim p as a decimal is 0.5, and the significance level is 0.05. And it does mention higher, my bad. And then the null hypothesis is p equals 0.5, and the alternative hypothesis, h1p, is greater than 0.5. The test statistic is negative 5.477. Critical values is negative 1.644, and the p-value again is 0. My conclusion is that at the 0.05 level of significance, I would say that a majority, 50% or above, of body temperatures for this population is below 98.6. The sample does have significance evidence to say that the majority of the body temperature is below 98.6.